everyone. Today I will be presenting ScanDetective, a Windows security monitoring application developed as part of my cybersecurity capstone project. When I began designing ScanDetective, my goal was to create a simple security monitoring application that focused on my own computer rather than an entire network. Existing tools such as Wireshark provide an enormous amount of network information, but I found them overwhelming for quickly identifying suspicious activity on a single machine. I wanted an application that displayed only the information that was most relevant for detecting potentially malicious behavior. The primary attack I chose to focus on was the reverse shell. Reverse shells are a common technique used after an attack has already compromised the system, allowing the attacker to remotely execute commands on the victim's computer. My objective was not to build a complete endpoint detection platform, but to demonstrate that this type of activity can still leave observable indicators that a monitoring application can detect. To accomplish this, I developed the network scanner using the Windows API. Instead of simply listing every network connection, the scanner gathers info about each active connection, including the owning process ID, memory usage, elevation privileges, local and remote IP addresses, port numbers, and connection state. These characteristics are combined into a risk score that helps identify processes requiring further investigation rather than relying on a single indicator. Then, as an example, so here on the Windows machine, I'm gonna download the virus from a pre-made website that I use just for this demonstration. It does flag by Windows that it's suspicious, but you can still get around that very easily. So what ScanDetective will do is show that this was recently downloaded and that it is suspicious. As you can see, I'm looking for it, and there, mine.exe is right there. Then you can examine the file data to see that if it has any suspicious strings, and it indeed has a lot of them. It also has entropy, but this is not a reliable way to know if it's malware or not. It's just another it's just more information. This would be an example of the reverse shell getting detected on ScanDetective. So first you start the bind shell, then the listener, and as you can see, it is connected. Here in ScanDetective, you would run advanced scan. View logs. Since it's a since it's a reverse shell, and it's listening on 4444, you would put that in the filter, and this is it. Python.exe. It's unknown, it's critical, it doesn't have elevated, but this is the attack. On the other hand, if you try to do this on an admin account, as you can see, it's connected. Run advanced scan again. Use admin access. And view logs again. Filter again. 4444. And this is the one with the admin access. As you can see, it's elevated, and it's even more critical because it's elevated. It's the same attack, just with admin access. So it shows elevation. To tie everything together, I integrated a SQLite database into the application. Every network scan and file examination is stored in the database, allowing users to search, filter, and review previous results through the graphical interface. This provides a centralized location where network activity and executable analysis can be viewed together rather than as separate tools. During development, I originally planned to implement a complete authentication system with user registration and account management. However, due to this project's scope and available development time, I simplified this feature to a basic administration login so I could focus on the core security functionality of the application. Overall, the purpose of ScanDetective is to demonstrate how network monitoring, static file analysis, and behavior-based risk scoring can be combined into a practical educational security tool. Rather than attempting to identify every possible threat, the application highlights suspicious activity so that the user can investigate it further.